Hi, this is Tom English again, and I covered a little bit of mixed numbers in our last video, but I wanted to go into it in a little more depth because it is probably the area of fractions that causes the kids the most difficulty. If, again, in reviewing, a mixed fraction is a whole number and a fraction, and let's say we want to add a mixed number. Let's do 2 1/2 plus 3 3/8. Okay? We again said we have to do these whole numbers separate and the fractions separate. And in the fractions, we know in order to add fractions we must have a common denominator. So when I look at this, I'm going to convert 2 and 8. I can see that the common denominator would be 8. So I'm going to convert 2 1/2 to 2 and how many eighths? Well, 2 goes into 8 4 times. So I had to multiply this by 4. I have to multiply the numerator by 4. So that becomes 2 4/8. This stays the same. We have 3 3/8. And nicely, if we're going to add, we add 4/8 and 3/8 and get 7/8. And 2 plus 3 is 5. 5 7/8 would be our answer there. Pretty straightforward. Let's do a subtraction. Let's say that, let's switch these numbers around, and let's say we've got 3 3/8, and we want to subtract 2 1/2. Now again, treat the fractions separate. We must have a common denominator. We've already said the common denominator is 8. So I'm going to leave this one as 3 3/8. And this becomes again 2 4/8. And we want to subtract. Uh-oh. What's the problem? We can't subtract 4 from 3, can we? What do we do with other subtraction of whole numbers when we couldn't? Let's say we had, a simple problem. Let's say we had 32 and we wanted to subtract 24. Well, we said we can't subtract 4 from 2, so what do? We had to borrow 1 from the next column, didn't we? We borrowed 1 from the 3. That made that a 2. 1 in that column gives us 10 in this column. So when we borrowed 1 from that, we added 10 to the 2 to give us 12. Now we can subtract 4 from 12 is 8, and 2 from 2 is 0. So that's how we were able to subtract that smaller number, or the larger number from the smaller number. We have to do the same thing with fractions. We can't subtract 4/8 from 3/8, so what we're going to have to do is borrow 1 from the whole number. We borrow 1 from the 3, that's going to make it 2, but it's 2 and how many eighths? Well, when we borrow a whole 1, how many eighths are we borrowing? Well, we're borrowing 8/8, aren't we? So we look at this and we say when we borrow 1 from the whole number, we're borrowing 8/8. We had 3/8. That now gives us 11/8. Then can we subtract 2 4/8? Sure, 4 from 11 is 7, and 2 from 2 is nothing, so therefore our final answer is 7/8. That borrowing is something that really causes some problems with the students. So I want to go over that one more time. Let's maybe do something that's a little more difficult. Let's use some numbers. Let's say we have 4 3/4, and from that we want to subtract 2 9/10. Okay? Again, first thing, what do? We have to get a common denominator. common denominator between 4 and 10. Well, when I look at 4 and 10, I say 4 won't go into 10 right away, but what if we doubled 10? If I doubled 10, then I got 20, and 4 will go into 20. So I'm going to use 20 as a common denominator. I change both of these to 4 and how many 20ths, and this becomes 2 and how many 20ths? Well, 4 goes into 20 5 times, so I have to multiply 4 times 5 in order to get 20. Again, whatever I do from the to the denominator, I also have to do to the numerator. So that becomes 3 times 5, or 15 20ths. 10 goes into 20 2 times, so I had to multiply this by 2. I have to multiply the numerator by 2. That becomes 2 and 18 20ths. Again, we're subtracting, and we're trying to subtract 18 from 15. Doesn't work, does it? We're going to have to borrow 1 whole from the 4. We borrow 1 from the 4, that's going to give us a 3 there. But 1 whole is how many 20ths? Well, of course, it's 20 20ths, isn't it? So when we're borrowing 1 whole, we're borrowing 20 20ths. And if we add 20 20ths to 15 20ths, we now have a number 3 and 35 20ths. Everybody see that? It's important that you recognize when you're borrowing 1 whole, you're borrowing the fraction that's equal to 1. Whatever the denominator is, the numerator will be the same. Then you can add that to the 15, so we have now 3 and 35 20ths minus 2 and 18 20ths. Okay? 35 minus 18. 8 from 5. Well, we have to borrow. This becomes 2. This becomes 15. 8 from 15 is 7. 1 from 2 is 17. So this becomes then 35 minus 18 is 17 20ths. 3 minus 2 is 1. That's our new answer. Okay? Let's take a moment and multiply by mixed numbers. That's really a little difficult, or a little, it's not so much difficult once you have done a few, but a little different than anything that we've done so far. But let's say that we wanted to multiply the mixed numbers. Oh, let's make it easy. Let's say 1 2/3 times 2 1/2. Okay? In this case, we can't multiply both the fractions and the whole numbers. What we have to do is we have to convert these back to an improper fraction. And then when we have fractions, even though they're improper fractions, we can use the same rules that we learned, just multiply straight across. So how do we convert a mixed number back to improper fraction? Well, we simply multiply the denominator times the whole number and then add the numerator. In this case, we're saying 3 times 1 is 3 plus 2 is 5. That becomes 5/3. Okay? And hopefully you can see that 1, if we just did it in thirds, is 3/3. That's why we're multiplying the denominator times the whole number. But then we had to add the 2/3 to it, which gave us the 5/3. 2 1/2, what is that as a improper fraction? Again, 2 times 2 is 4, plus 1 is 5. So that becomes 5/2. Again, if we think of that, we say 2 is how many halves? Well, 2 halves, or 2 is, the whole number 2 is 4 halves, and then we had 1, so we have to add the 1, and we end up with 5 halves. Now, even though they're improper fractions, they are fractions and we can multiply. When we multiply straight across, don't we? 5 times 5 is 25. 3 times 2 is 6. Now we've got an improper fraction. What do we do with it? We reduce it. How do we reduce it? Divide the denominator into the numerator. 6 goes into 25 4 times. 4 times 6 is 24. Subtract, we got 1 left over. Our answer becomes 4 1/6. Okay? A little more involved, a little more difficult. But again, if we can remember, in order to multiply by mixed numbers, we have to first convert them into improper fractions. Once they're improper fractions, we multiply straight across. Then we end up with, in many cases, we're going to end up with an improper fraction. We turn around and reduce that into a mixed number. So 1 2/3 times 2 1/2 is equal to 4 1/6. What do you think, how do you think we would do division? Same way, we get to the same point. The difference is that if this were division instead of, we first have to get it into its fractional form, even though they're improper fractions. It's division, so what do we say about division of fractions? What do? We invert and multiply. So that then becomes 5/3 times 2/5. Conveniently, the 5's cancel, and if it's division, the answer is 2/3. Okay? Hope you picked that up. If not, play it over a couple times. And again, let me know if your child has a little difficulty with this. If you need some different kinds of practice and so forth, please give me an email, and I'll come up with some maybe additional lessons, additional worksheets, and so forth. Thank you much.